All right, what about rolling a pair of dice? And I'm interested in the number of spots that show on top of the 2 dice. Let me say that slightly separately. I'm going to roll a red die and a blue die, and I'm interested in the number of spots that show on each of them. What does my outcome space look like? Sorry? No, I'm not the sum of the numbers that show, but the numbers that show on each face. So we have 2 dice. Okay, so I have pairs of, my outcomes are comprised of pairs of numbers, right? How many numbers show on the first die? How many numbers show, how many spots show on the first die? How many spots show on the second die? Yes? Okay, so my outcome space looks like 1, 1, 1, 2, 1, 3, etc. 1, 6, 2, 1, 2, 2, on up to 2, 6, etc. on up to 6, 1, up to 6, 6. Okay? So how many things are there in this set? So this would be S. Six times 6, right? There's 6 choices for the number of spots on the first die, 6 for the number that show on the second. Fundamental rule of counting says the total number of possibilities is 6 times 6, because knowing that, no matter what I get on the first die, I still have 6 choices for what happens on the second. Yep. So the number of elements in S, cardinality of S, is equal to 36. Okay. And so what's the event that I roll a 7? That the sum of the spots on the 2 dice is equal to 7? Yeah, just saying the sum of the spots showing on the 2 dice is 7. What does that look like? Okay, so it's a subset of the outcome space, right? Okay. What does that subset consist of? 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. Okay. 1, 2, 3, 4, 5, 6 elements, right? Okay, so for the uniform distribution on pairs of rolls, what's the probability that I roll a 7? So it's the number of elements in that set divided by 36, which is 6 over 36, which is 1/6. Okay? Is this everybody with me? Okay.
Does uniform distribution between the probability? Is that what you're asking when you say that? Or?
Well, I mean, if the dice were weighted, then these wouldn't have a uniform distribution. You wouldn't have a uniform distribution on these pairs. If the dice are fair, that's kind of what we mean, that every one of these outcomes is equally likely. This is sort of tied to the theory of equally likely outcomes. We're saying that, according to the uniform distribution, the elementary outcomes are equally likely. And as a result, the probability of some event is equal to the number of outcomes in that event, the number of elementary outcomes in that event, divided by the total number of elementary outcomes. So in this case, the probability of that I get any of these 6 disjoint things is equal to a 36 plus a 36 plus a 36 plus a 36, et cetera.